Amorphous forms of carbon. Carbon is one of the most important elements for existence of life on Earth. In fact, it is widely found in different forms. Carbon can occur in amorphous forms. The word amorphous means lacking in form or shape. This means that the atoms or molecules of amorphous substances are not arranged in a regular geometric pattern. The amorphous forms of carbon are coal, coke, charcoal, lamp black, and gas carbon. They contain nitrogen, oxygen, hydrogen, and sulfur as impurities. Coal is a very cheap fossil fuel and is found in Russia, China, USA, Germany, South Africa, and Australia. Large deposits of coal are also found in Jharkhand, West Bengal, Orissa, and Madhya Pradesh. These deposits of coal were formed through a long process known as carbonization. Carbonization occurred primarily in the Carboniferous era about 270 million years ago. Bacterial decomposition of vegetable matter under several layers of earth resulted in the formation of coal. High temperature and pressure and the absence of air aided the process of carbonization. With each successive layer of coal, the amount of carbon present in the deposit increased, and the level of impurities decreased. Thus, 4 types of coal were formed: peat, lignite, bituminous, and anthracite. Peat is the first stage in the formation of coal. It is light brown, contains 50 to 60% of carbon, and is the most inferior form of coal. Lignite is the second stage in the formation of coal. It is harder than peat and also brown in color. However, it contains more than 60% carbon. Bituminous coal is the next stage, and its carbon content can vary from 70% to 90%. It is the most common form of coal and is also known as household coal. It is black, hard, and gives out volatile and non-volatile substances on heating. Anthracite is the oldest stage and also the purest form of coal. Its carbon content varies from 92% to 98%. It is hard, dense, black, and difficult to ignite. However, when ignited, it gives off tremendous heat and burns for a long time. Coal can be used as both a domestic and industrial fuel. It is used in homes, thermal power stations, steam engines, and furnaces. Coal is also used to prepare coke, coal gas, and coal tar. It is used in the manufacture of synthetic petrol. Coal is a necessary component in the manufacturing of fertilizers, drugs, synthetic textiles, and perfumes. It is also the source of organic compounds such as benzene and naphthalene. Destructive distillation of coal yields products such as coke, coal gas, coal tar, and ammonia solution. Destructive distillation refers to the decomposition of a substance when heated in the absence of air. It results in a carbon-rich residue. To carry out destructive distillation of coal, powdered coal must be placed in a hard blast test tube. When it is heated strongly, it forms a gray porous residue that lies in the tube. This is coke. At the same time, dark brownish vapors are given out. Carbon particles from these vapors solidify at the mouth of the test tube and are known as gas carbon. When these vapors are passed through water in a conical flask, they condense to form two distinct layers. The lower layer is a thick, black liquid called coal tar, while the upper layer contains ammonia liquor. A colorless gas bubbles out of the conical flask and burns with a yellowish flame when ignited. This gas is commonly known as coal gas. Let us take a closer look at the coke formed through destructive distillation of coal. Coke is a black, porous, solid substance that burns without smoke. It contains 98% carbon and is a bad conductor of heat and electricity. There are two types of coke. Hard coke is lustrous and light and is used in industrial furnaces. Soft coke, on the other hand, is black, porous, ignites with difficulty, and is used in household furnaces. Coke has several uses. It is used as a smokeless fuel and as a reducing agent in the extraction of metals from their ores. It is also used in the manufacture of water gas, producer gas, and artificial graphite. Coke is used in the preparation of metallic carbides such as calcium carbide. Fractional distillation of coal tar yields a number of organic compounds that can be used for making dyes, drugs, and explosives. The other products of destructive distillation of coal also have many uses. Purified coal gas is used as an industrial and household fuel, while ammonia solution is used in the preparation of artificial fertilizers. Charcoal is a black, porous solid produced when organic substances or plant of animal origin are subjected to destructive distillation. Let us take a look at the different types of charcoal available. Wood charcoal is a black, porous, brittle solid obtained by burning wood in a limited supply of air. Logs of wood are piled on top of each other and covered with a layer of wet clay. A gap is left in the center of the pile and the wood is burnt. When the fire dies out, wood charcoal is left behind. Wood charcoal can also be prepared in the laboratory. When sawdust is heated, a gas that burns with a blue flame is liberated. This is called wood gas. The second test tube in this experiment contains a liquid. The lower layer is dark colored and is known as wood tar, while the upper layer is colorless and is known as pyroligneous acid. If the sawdust is continually heated, it chars to a black mass. This black residue formed in the first test tube is wood charcoal. Although wood charcoal is heavier than water, it floats on water. This is because of the air it holds within its pores. If the air is removed by boiling the water, the charcoal settles down. Just like coke, wood charcoal is also Wood charcoal is placed in a test tube containing hydrogen sulfide gas. After a while, the smell of rotten eggs disappears. Wood charcoal absorbs the gas. Similarly, if wood charcoal is introduced into an ink solution, the color of the ink fades away. The ink is absorbed by the pieces of wood charcoal. The absorption power of wood charcoal can be increased by heating it up to 900 degrees Celsius by steam. This opens up its pores and increases its capacity to hold more gas. Such charcoal is known as activated charcoal. Wood charcoal also has chemical properties. When it is heated in air to 100 degrees Celsius, it burns without a flame to form carbon dioxide. In a limited supply of air, however, carbon monoxide is formed. Wood charcoal reacts with nonmetals like hydrogen and sulfur to form methane and carbon disulfide respectively. It also reacts with metals such as calcium at a high temperature to form calcium carbide. Wood charcoal is a strong reducing agent. It reduces metallic oxides such as copper oxide and lead oxide to their respective metals and also produces carbon monoxide. When superheated steam is passed through white-hot charcoal, the steam is reduced to water gas. Wood charcoal also reduces concentrated sulfuric acid to sulfur dioxide and concentrated nitric acid to nitrogen dioxide. Silicon dioxide or sand is reduced to silicon carbide by wood charcoal when heated strongly in the presence of an electric spark. Wood charcoal is used as a fuel because it burns at low temperatures and produces no smoke. It is also an important constituent of gunpowder. As wood charcoal has a high absorbing capacity, it is used in gas masks to absorb harmful gases, in the form of tablets to relieve gas troubles, to decolorize syrups and refine fats and oils, etc. Another form of charcoal is sugar charcoal. It is the purest form of amorphous carbon and is prepared by heating cane sugar or glucose in the absence of air. It can also be prepared by the dehydration of cane sugar or glucose in the presence of concentrated sulfuric acid. Sugar charcoal is used as a reducing agent to extract metals from their oxides and to decolorize colored solutions. It is also used in the preparation of artificial diamonds. Destructive distillation of bones produces bone charcoal along with bone oil and the organic compound pyridine. Bone charcoal contains mainly calcium phosphate and only 10 to 12% of carbon. The carbon content of bone charcoal is separated by using hydrochloric acid, which dissolves calcium phosphate. Carbon is filtered out of the solution and in this form is known as bone black or ivory black. Bone charcoal is used to decolorize cane sugar and also in the manufacture of several phosphorus compounds. Lamp black or soot contains 98 to 99% carbon. It is prepared by heating carbon-rich substances like kerosene oil or turpentine oil in a limited supply of air. The oil burns with a smoky flame that contains large amounts of free carbon. The black smoke is collected in the form of black powder over damp blankets kept inside chambers. This powder is lamp black. It is a light black powder and is used in India as kajal or surma. It is possible to prepare lamp black from vegetable oil. Place a cotton wick in an earthen bowl containing ghee or vegetable oil. Then light the wick and hold a metal plate over the flame. Black powder gets deposited on the surface of the plate. This powder is lamp black or kajal. Lamp black is used in the manufacture of tires, gunpowder, black shoe polish, carbon paper, black paint, etc. Gas carbon is prepared by the destructive distillation of coal or when petroleum products are heated at high temperatures in closed containers. The carbon particles deposited on the sides of the container are gas carbon. Gas carbon is a grey solid and is a good conductor of electricity. It is used for making electrodes of dry cells and carbon rods for arc lamps. The various amorphous forms of carbon available to us on Earth can thus be used in homes as well as industries.